Hello, my name is Annabelle Polk. This is my second video for Project 1. We will be using 40 hertz as our frequency. I'll just go ahead and jump into it. Again, grab fluid, put it in here. Like that. Need to change the properties of our geometry there. 2D, because we're making a 2D one tunnel. New geometry. This might take a minute. So I am going to be right back. We're back. We're going to be working on the XY plane to sketch our wind tunnel. This doesn't really matter now, but just for muscle memory purposes, units that we are working in, at least dimension-wise, are in inches. So start at the center and make 4 line segments for each part of our wind tunnel. Dimensions, make the given dimensions here. We'll just follow each of the lengths. We got 15, 24, 12, and 42. 15, 24, 12, 8, 42. Perfect. Now we're going to back to draw a line, make 5 vertical lines. That was about, Strengths, midpoint, move all of, oh, that's not what I wanted. And midpoint. Apologize if I move a lot. I have poor eyesight. Okay, we've moved all of our edges, and now we need to dimensionalize them as well. Except for our last one, we weren't really given a dimension for that, so we're going to use the half diffuser angle of 3 degrees. But before that, we can go ahead and do our other ones, which are, it's going to be 22 for both, or 22 for the first two, and 6 for these other two, which are test section. 22 and 6. Perfect. Draw, line. Now we're going to connect all these. All right. Back to 2 dimensions, angle from here to here, angle. We're given 3 degrees, pardon me, diffuser angle of 3, half diffuser angle of 3 degrees. Meaning we're going to make this 177, subtracting that 3 degrees for our outlet. Perfect. And then delete all these extra pieces. Concept, surface from sketches. We are going to use our sketch 1, apply, generate, boom. And then we're also going to go to meter, back to meter, because now we're going to find the full length of our wind tunnel that we'll need for later, but we're going to do now for the sake of my computer. Nope, analysis tools. Distance finder, and we have to click the edge piece here because we want this edge, apply, versus this edge. And we can see it's 2.3622, just like in our last video. Workbook, geometry, update. Perfect. Update mesh as well. Don't forget that. She's loading. Yeah. We're back. We can finally click mesh and then double click mesh. Wait for this to open as well. This also might take a while, so I will be right back. All right, we are back. This is what has opened up for us. We can also go ahead and just click out of this since we've updated everything. Just gonna give it a minute to settle. Okay. Now we are in mesh, mesh, and then right click mesh. Apologies. We're in it. Apologize. Mesh insert method. Select our whole geometry. We can also move this to our XY plane. And then apply. Perf. Ah, triangles. Generate. We have all these really big ones, but we are going to slow them down to 0.01. Click on mesh. You can see all these tiny little baby triangles. And that is, oh, I almost forgot. We're also going to go ahead and name these walls in our mesh analysis so that when we go to setup, these are already ready for us. We'll go ahead and just name this one, just like last time. And select this, and this will be our wind tunnel output. Okay, and wind tunnel inlet. All right. Done here, back to workbook. Update mesh. Hello. Sorry, it's moving to load itself. Okay, back. Mesh. Mesh. Update. Let it update. All right. They're updated. Setup. Update. Let it load. Once this finishes updating, we can also get out of our, or exit out of our mesh. It's there. All right, it's finally loaded. Now we can go ahead and get out of this, which is also going to take eons. There we go. Double click setup. It's going to give us, there we are, double precision, set that to 2, not 12. Start. This one also takes a minute to load. Oh. When this pulls up, it looks a little something like this. You know you're good. Energy is already on. We're just gonna click it anyway. Energy. Okay. This K epsilon. Enhanced wall treatment, both pressure and thermal effects. Got it. Our next thing is going to be boundary conditions. We are going to change our inlet. Let me. When we use the velocity test section of 40 hertz using this equation here, we get 2.61 meters per second as our V1. A1, V1 equals A2, V2. Our V1 is going to be 2.61. There's actually going to be a bunch of decimals after that I'm also going to put in. Two 2.61272727. Apply. And close. Then we go down initialization. Initialize. It's all right. This morning is fine. Done. Run calculations. Number of iterators, whatever you'd like. Preferably higher than like 150, 100. Calculate. And we're gonna get this fun little graph here. I'm waiting for it to fully finish calculating. Just now. All right, so graphing contours. And this is where we can find the contours of the velocity, static pressure, dynamic, and total pressure that Dr. Ozbay wants. Center lines are here too. Well, not including the center line. That should not be there yet. Is just our bodies and our inlets, outlets, and wall to our display, not the center line. And this will be for static pressure, Come on. Dynamic pressure. Melting pressure. And finally, velocity. Perfect. From here, we can go to our plots, our XY plot. And this center line that we found in our first video from our geometry by taking the distance between the 2 points was 2.3622 meters, and that does not change for anything. So let's do the same thing again. Sure, do velocity first. Here's our velocity. Finish. Static pressure. Dynamic pressure. Total pressure. Wonderful. And then to save these graphs, write to file, put it in whatever folder you have for your project. And then you can do copying, pasting to Excel, or you can also export your whatever you opened this data sheet in to Excel, export it to Excel. That's what I meant to say. And that is going to be it. Oh, one thing for this project.